A cold object is placed in a warm room. Its temperature, C degrees, after time t minutes is shown on the following graph. Part 1. What is the intercept on the vertical axis? Part 2. Describe by a formula and words the relation between the time and the temperature. Part 3. If the temperature is denoted by C after time t minutes, find the values of m and k if C equals mt plus k. A second, larger cold object is placed in the same room at the same time as the first object. It starts with a temperature of -2 degrees, and after 5 minutes, its temperature has risen to 0 degrees. Part 4. Copy the diagram above and show on it the graph of the temperature against time for the second object. Part 5. Use your graph to determine the time at which the two objects have the same temperature. Part 6. Check your answer by calculating this time using algebra. So part 1. What is the intercept on the vertical axis? So the intercept on the y-axis is -3. So this is our vertical axis, or our y-axis, which represents temperature in degrees Celsius. And we can see the point at which the graph crosses the axis is -3. So our y-intercept is -3. Part 2. Describe by a formula and words the relation between the time and the temperature. Over each 6-minute period, the temperature rises by 3 degrees. So we can see this in the graph because at time 0, we had a temperature of -3. And then at time 6 minutes, we had a temperature of 0. So to get from -3 to 0 is an increase of 3 degrees. And then at 6, we have a temperature of 0. And then at 12, we have a temperature of 3. So again, we can see from 6 to 12 minutes, we had a rise from 0 to 3 degrees Celsius. So over each 6-minute period, the temperature rises by 3 degrees. Alternatively, the temperature increases by 0.5 degrees each minute. So 3 divided by 6 is 0.5 degrees. So in every minute, the temperature is increasing by 0.5 degrees. Part 3. If the temperature is denoted by C after a time t minutes, find the values of m and k if C equals mt plus k. So that's basically saying find the slope and the y-intercept. Well, the slope of the line is a half, and the intercept on the vertical axis is -3. So where did we get a half from? Well, we have a graph, and in order to get the slope of a line, we can choose 2 points on our graph and use our formula, our slope formula that's given to us in the formula tables. So I'm going to choose the point 0, -3. And I'm also going to choose the point 2, -2. And I'm going to label them x1, y1, x2, y2. So the point 0, -3 is going to be labelled as x1, y1, and the point 2, -2 is going to be labelled as x2, y2. Then I take my slope formula, which is m equals y2 minus y1 divided by x2 minus x1, and I'm going to substitute my values into my formula. So I get -2 minus -3 over 2 minus 0. -3 becomes +3. -2 plus 3 is 1, and that's going to be 1 over 2. So that's where we get a half from. So the slope is a half. And the intercept we already got to be -3. So thus, the equation of the line can be written as c equals a half t minus 3. So the half represents the slope, and the -3 represents the y-intercept. So a second larger cold object is placed in the same room at the same time as the first object. It starts with a temperature of -2 degrees, and after 5 minutes its temperature has risen to 0 degrees. Part 4. Copy the diagram above and show it on the graph of temperature against time for the second object. So the graph with both lines indicated is shown below. So the blue line was our original graph, and the green line is our new graph. So the green line represents the second larger cold object. So how did we draw this line? Well, we were told that the temperature starts at -2 degrees. So we know that one point on our graph is going to be 0, -2. And we were told that after 5 minutes, the temperature is 0 degrees. So we need to go to 5 minutes on our x-axis, and at 0 on the y-axis, plot our second point. So it's going to be 5, 0. So now that we know 2 points on our graph, we just join them together with a ruler and extend the line to the end of our graph. So part 5, use your graph to determine the time at which the two objects have the same temperature. So use your graph means we literally have to draw on our graph and use the graph. And we're interested where the two objects have the same temperature. So basically we're interested in finding where the two graphs intersect, the point of intersection. So from the graph, the two objects have the same temperature after 10 minutes. We can see this is the point at which they meet, and that lines up with 10 on our x-axis. So the two objects have the same temperature after 10 minutes. Part 5. Check your answer by calculating this time using algebra. So again, we got our time to be 10 minutes when the temperatures are the same. So we want to verify using algebra that this is correct. So we want to basically solve the equation simultaneously and get an answer of 10. So first of all, what we have to do is get an equation for the second line. So the slope of the second line is going to be 2 over 5. So again, to get the slope, we have to choose 2 points on the graph. So I'm going to go with 0, -2, which is here, and 5, 0, which is here. I label them x1, y1, x2, y2, and I substitute them into my slope formula, which is m equals y2 minus y1 divided by x2 minus x1. So I get 0 minus -2 divided by 5 minus 0. Minus -2 gives me +2, so I get 2 over 5. So the slope of the second line is 2 over 5. And the intercept is clearly -2. That's the point at which it crosses the y-axis. So the equation is going to be c equals 2 over 5t minus 2. The 2 over 5 is the slope, and the -2 is the y-intercept. So we're going to solve them simultaneously. So our equation from the first part is c equals 1/2 t minus 3. So that's the equation of our blue line. And the equation of our green line we just got is c equals 2 over 5t minus 2. So that's the equation of our green line. So we're going to let them equal to each other. So we get 1/2 t minus 3 equals 2/5 t minus 2. And we just solve for t. So we have 1/2 minus 3 equals 2/5 t minus 2. And we're going to bring the 2/5 t over the equal sign. And it becomes minus 2/5 t. And then we bring the minus 3 over the equal sign. And it becomes plus 3. So we have 1/2 minus 2/5 t equals minus 2 plus 3. So I'm going to simplify both of these by getting a common denominator, which is going to be 10, because 2 divides into 10 and 5 divides into 10. 2 into 10 goes 5 times, and 5 multiplied by 1 is 5, so we get 5t. Bring down the minus. 5 into 10 goes twice, and 2 multiplied by 2 is 4, so we get minus 4t, and minus 2 plus 3 is 1. So 5t minus 4t is just t, so that's t over 10, equals, and 1 can be changed to be 1 over 1, so that I can cross multiply and solve. So t multiplied by 1 equals 10 multiplied by 1, so t is equal to 10. So we have solved simultaneously our two equations and verified using algebra that the answer is 10. So the point at which our graphs will cross is 10. So t is equal to 10. The time is 10 minutes.